right, for the next problem here, we want to solve x plus 1 over the square root of x plus 1 equaling 2. So like most strategies here, you want to bring everything to the numerator. So I'm going to go ahead and multiply across by the square root of x plus 1, giving us x plus 1 equaling 2 to the root of x plus 1. Now, whenever you're solving an equation involving a radical, you typically want to isolate the radical and square both sides. So I'm going to go ahead and square both sides of this equation, giving me x plus 1 squared equals 4 times x plus 1. And then I'm going to go ahead and bring everything to one side. Now, you could expand this out, but I'm noticing that if I do bring everything to one side, I can go ahead and factor out the x plus 1, leaving me with x plus 1 minus 4 equaling 0, in which case I get x plus 1 times x minus 3 equaling 0, and we find our two roots here of negative 1 and 3. Now you got to be careful here. Whenever you square both sides of an equation, you open up the opportunity of extraneous roots. So I actually have to check both of these in the equation and see if they're admissible. Now when I go and check the minus 1, right away you see that's outside the domain of the equation here. You'll notice here that the assumption here is your x value must be greater than negative 1, your solution set. Like the domain of this function here is greater than negative 1. So negative 1 is outside of our solution set here. So that's inadmissible, and that's came about, and we solved that because we square both sides of the equation. So we end up getting a root that wasn't there, didn't actually exist. But 3 should work. Let's take a look and sub a 3 into here and see. If I do left side, right side on this, if I sub x equals to 3 on the left-hand side, I'm going to get 4 in the numerator. And this will be 3 plus 1, which is 4 to the root is 2. And that'll reduce to become a 2, which, as you know, the right-hand side is equal to 2. So we can see right-hand, right-hand side here, check works out. And 3 is the only solution to this problem here. Let's take a look at another. So for the next problem here, this is a logarithmic equation they want us to solve. I have log x, so the assumed base is 10 here. If they don't write the base, it's base 10. So I have log base 10 of x equals the square root of log base 10 of x to the power of 13 over 6 minus 1. So this is intended to be all in the exponent. So this is x to this power. So let's go ahead and solve this problem here. First thing you want to do is apply your logarithmic properties where you can. So I've got my log base x. Always write things back in exponential form, especially when working with your logarithms. So this is 13 over 6 minus 1. This is to the power of a half. So using my logarithmic rules, the first rule I can do is I can drop my exponent down. So I can rewrite this as 13 over 6 log of x minus 1, again to the power of a half. Now, I cannot drop this half down. That's not a logarithmic rule. But what I can do is I can square both sides of the equations. This becomes log squared of x is 13 over 6 log of x minus 1. Now, if I bring everything to one side, I get log squared x minus 13 over 6 log of x plus 1 equals 0. All right, now that we have this here, I'm going to go ahead and multiply across by 6, in which case I get 6 log square root of x minus 13 log of x plus 6 equals 0. Treat this just like a quadratic. I'm going to go ahead and can do charting or decomposition to try to factor this. So I'm going to do the factors of 6 and the flips. Again, you can just do decomposition. And I need to get product diagonals whose sum comes out to be negative 13. Excuse me, there should be a minus sign there. And we can see here that these two columns work. So this is going to end up factoring into 2 log x minus 3 times 3 log x minus 2 equaling 0. So we have the product of two expressions is 0, which means that the log of x is equal to 3 halves, or the log of x is equal to 2/3. Converting this to exponential, I know that x is going to be 10 to the exponent of 3 halves, or x is going to be 10 to the exponent of 2/3. And that becomes our two solutions for this question. All right, let's take a look at one more. So for the last and final question here, we want to go ahead and solve the following question. We've got here the square root of x to the power of x is equal to x to the power of square root of x. So with something like this, you always want to go to exponential form to see what you're working with, see what rules you can apply. So this is x to a half represents the square root of x. That's all to the power of x. And this is x to the power of x to the half. So right away working with this one, I have power to a power you multiply. I can write this as x over x to the half is equal to x to the, I'll just write that back as the square root of x. So solving this one here, we can see that these are equivalent, assuming that x over 2 is equal to the root of x. So I want to solve this equation here, in which case multiply across by 2, you get x equals 2 root x. X minus 2 root x is 0. Can factor out that root of x here, in which case I get root of x minus 2 equaling 0. And then I can go ahead and solve this here. All right, so solving for this here, you have two options. Either the root of x is 0 or the root of x minus 2 is 0. This one will imply the root of x is 2, in which case you get x is 4. This implies x is 0. Now we have to watch out here. With these two answers here, x is 4 is a solution. We can use that one. This one here, we have to watch out because how I got from here to here, I took the log of both sides. So what I did was I took log x to the power of x over 2 is log of x to the root of x. And then my exponential rules say I can drop down the logarithm, do it once more, and then we can sort of cancel these off. But the idea here is that this function needs to be defined. But the domain, if someone gives you the log of x, x must be greater than 0 here, your input value. Can't take the log of a negative number, and you also can't take the log of 0. So therefore, 0 is outside of the domain when I do that. So I end up getting here x equals 4 for this one here. And now finishing this off here, we've got our root at 4. And then I want to go ahead and consider the case, well, okay, what happens if log of x is equal to 0? If log of x is equal to 0, we end up getting 10 to the 0 is x, in which case x is 1, and that's our second root to this equation here. So solution set for this is going to be 1 and 4. Thank you.